So we are taking indefinite integrals class 12 RD Sharma solution exercise 19.30 of chapter 19. Now 2x divided by x square plus 1 divided by x square plus 3. Now we have x square into x square, that is x raised 4 in the denominator, only x in the numerator. But if we just take this x square equals to t, that is we will try to minimize the effort. When we differentiate dt by dx will come as 2x. So what are you going to get? Dt will be equal to 2x dx. So this 2x and dx will give dt. We'll replace this here. So this integration will become like this. Integration of dt divided by, after replacement of x square with t plus 1, first factor, and t plus 3 as another factor. So we will try to form partial fractions out of this. That is, right now we are not integrating. We are just trying to form partial fractions out of this 1 by t plus 1 multiplied by t plus 3 in the denominator. So this will be equal to a divided by t plus 1 and then b divided by t plus 3. So this is 1 by t plus 1 into t plus 3. This equals cross multiply, that is a with t plus 3 and b with t plus 1. And denominator will give you t plus 1 into t plus 3. The denominator gets cancelled. So this is equation number 1. If we place t equals to negative 3, the first term of the right hand side of equation number 1 will vanish. So we have t equals to negative 3 on the left and right also. So we will get b equals to negative 1 by 2 here. Now when we place t equals to negative 1 or replacement of t equals to negative 1 will give the second term the value 0. So a we will get from here after replacing t equals to negative 1. So 1 will be equal to a into 3 minus 1, which is 2. A became 1 by 2. So we'll place a as half and we'll replace b by negative half and then we will integrate. So the integration will be like this. Integration equals to half integration of dt divided by t plus 1 minus half integration of dt divided by t plus 1, t plus 3. So we know integration of 1 by x or 1 by t with respect to dx or dt will always give you log. So log modulus of x or log modulus of t. This log is log base e. You can always write interchangeably ln also in this place. So half ln modulus of t plus 1 here, and then we have ln modulus of t plus 3 here. Half and half you can take common. This will be ln t plus 1 minus ln t plus 3. So it will be log a minus log b. So this will be log a divided by b, that is ln a divided by b. So we have ln t plus 1 divided by t plus 3 with a modulus plus a constant of integration. Now if you remember, t was taken as x square or assumed to be x square. So now replace t by the original thing which was given in the question, which is x square. So half ln x square plus 1 divided by x square plus 3 plus a constant of integration, and this will be your final result. Now this is how we are going to do this. This is quite an easy question. The only trick is x square equals to t has to be put in to make it easier in order to formulate it in the form of integration of partial fractions. Putting, then all these you have to write. Logic is clear to you. Integration of 1 by x log x and 2 plus log x. Now in first view it seems what do we do with this log x? But if you take this log x and try to convert this integration in a formal in partial fraction way, it will be quite easier. That is, if you take t equals to log x or replace t with log x, this dt by dx will be equal to 1 by x. So this dt became dx by x, and you see in the question dx by x is already given to us. It's already there. So integration will be equal to, in place of dt or in place of dx by x, write dt. What else is remaining? Log x we have already taken as log x and t, and 2 plus log x means 2 plus t. So we need to find out the partial fraction. It will be quite easier because 1 by t and 2 plus t is straightforward. We don't have to worry about the order of numerator and denominator. It's the denominator has higher order. So you can have a divided by 2, t plus b divided by t plus 2. So we are actually finding capital A and capital B. So take the LCM on the right hand side, a multiplied by t plus 2 here and then b multiplied by t here. Denominator will give you t into t plus 2. Now this denominator gets cancelled. You have a and you have b. For that, first, in order to find out these two, t equals to -2, first we'll put. So the first term on the right hand side will become 0. Only b will come. From here to here, it will vanish. It will go. So 1 equals b multiplied by -2. From this, b is -12. Now this is done. Coming to the second constant, if you put t equals to 0, the second term of the first equation will become 0. So now place t equals to 0 everywhere on the left hand side and right hand side. A became 1 by 2. Now what we are going to do here is, we are going to write it as partial fractions. So how did we write it? A divided by t and then b divided by t plus 2 or t plus 2 to 2 plus t. Now when we integrate this, we'll replace a and b by half and -12 respectively. So I'm taking this half outside. If you want, you can take, because half and half can be taken outside. Only this a by t and b by 2 plus t will remain. So integration of dt by t in one case, followed by integration of dt by 2 plus t or t plus 2 in another case. So when you take this half outside, so let's take it outside. dt by t will be simply ln modulus of t, and this will be dt by t plus 2 will be ln modulus of t plus 2. So log a minus log b will come, and log a minus log b is simply log a by b. So log a minus log b, it's log t minus log t by 2. So it will be ln t divided by t plus 2 inside the modulus sign. Modulus sign is necessary, plus a constant of integration. Now I'm just writing here because I just want to complete this in this screen only. Half ln modulus of, now t was taken initially, remember, it was log x. So replace t by log x now. So log x divided by log x plus 2 and plus a constant of integration. This is your integration I. Alright. So this is the result I was talking about. There is just one thing. If you are able to understand that log x can be placed as t, other things are quite obvious and will be easier for you. Alright. Now here we have x square plus x plus 1, and in the denominator we have x square plus 1 and x plus 1. So the power in the numerator or the order of the numerator is 2 and denominator is 3. But you have a quadratic equation in the denominator, x square plus 1, which is in the denominator. This x square 1, we need to try some other thing here, which I explained you earlier also in the beginning of this discussion of this chapter. So x square plus x plus 1 divided by x square plus 1 into x plus 2. Now this can be written, we are just talking about partial fraction right now. I'm not integrating right now. So this will be a divided by x plus 2, because x plus 2 is a simple linear equation. So we can have a constant, one constant upstairs. But x square plus 1 is not a linear equation. It is actually a quadratic equation, because x square minus 1, if you remember, it can be replaced by x minus 1 into x plus 1. But x square plus 1 cannot be divided into factors. That's an issue. For that, because denominator has quadratic equation, we have to write bx plus c in the numerator, which will be above x square plus 1. Now let's take the LCM in order to find out this a, b and c capital. So a into x square plus 1 plus bx plus c into x plus 2, and in the denominator we are going to get x plus 2 into x square plus 1. And on the left hand side nothing is changed. We are just writing it so that we can say that what is the question and how we are going to form it. The denominator will get cancelled. We will equate now, that is, we'll equate the similar terms. For that you have to multiply a with x square plus 1, bx plus c with x plus 2. Left hand side x square plus x plus 1 only remains. On the right it will be a into x square plus a after multiplying these two, then bx plus c. So bx plus c multiplied by x, then bx plus c multiplied by 2. So bx square plus cx you can write, then bx into 2, 2bx, and then 2c. Now just combine or collect the similar terms. That means a plus b into x square. The first thing is this one, and a plus b into x square. Then we will go for the term with x. So the constant will be c plus 2b. This we have already used. Now a plus 2c. So there are three terms which we can equate. We have to equate the coefficients. So x square has a coefficient 1, x square has a coefficient a plus b on the left and right respectively. So a plus b will be equal to 1, c plus 2b with the same logic equals to 1, and a plus 2c same logic will become 1. So if you are able to solve these three equations, you will get A, B and C. So you can do it in any way. This is very simple for you, but I am trying to make it minimum effort taking. So I am writing A plus B below A plus 2C. Subtracting these two, 2C minus B equals to 0. So 2C became equal to B, or you can write C equals to B by 2. Now C and B are together in the middle equation. Now you can replace here C by B by 2. 2B is already there. It's equal to 1. So this will be 1 half plus 2 is it's 5 by 2. So you'll get B equals to 2 by this 5 by 2. 2 by 5 becomes when it goes on the right. Now you can put B here to A plus 2 by 5 equals to 1. A will become 1 minus 2 by 5. It's 2 by 5. So 5 minus 2 by 5 is 3 by 5. So A become 3 by 5. Now coming to A plus 2C equals to 1. A is 3 by 5. A plus 2C is already what we have to find. So this C will be 1 by 5 in this case. Now A, B and C we have got. Now we are going to replace it here. A by 3 by 5, B by 2 by 5 and C by 1 by 5, and then we will separate them out and integrate them separately in 3 terms as 3 different partial fraction terms. So this I will become like this. 3 by 5 was A, if you remember. The remaining thing inside integration we can have dx divided by x plus 2. Now the second term has bx plus c. B was this 3 by 5 divided by x plus 2. This was the first term. The second term was bx plus c. So 2 by 5x plus 1 by 5 divided by x square plus 1. Now you need to separate the second term into 2 more terms. That is, I am writing this term right now. So we have 2 by 5 integration of x divided by x square plus 1. Dx will always remain there. The second term will be 1 by 5 you can take outside. Integration of this dx divided by x square plus 1. In middle term also just assume dx is already there. Now x plus 2, it's quite obvious that it will be log base e modulus of x plus 2. Call it as I1, I2 and I3. So 3 by 5 I1 plus 2 by 5 I2 plus 1 by 5 I3. This is the whole scenario which is unfolding. So 3 by 5 into ln modulus of x plus 2, which is very straightforward. This is 2 by 5 and this will be 1 by 5. Let's find out I2 and I3 separately. I2 will be equal to x divided by x square plus 1 dx. Now just put this x square plus 1 as u or some t. It's up to you, any constant you can use. So this dt by dx will give you twice of x. So dt will be equal to 2x dx. That is, if you want to have x dx, it will be equated to dt by 2. So this x dx will be dt by 2. Half you can take outside. X square plus 1 has been taken as t. So this will be simply log modulus of t. Half log modulus of t plus constant of integration. Now this will be half log, what was t? It was x square plus 1 plus constant of integration. So we have 2 by 5 here. So 2 by 5 into 1 by 2, then ln modulus of x square plus 1. So this is I3 now. Let's find out I3. It's dx by x square plus 1. Now let me tell you, it has a direct result. But even if you want the same procedure which we have done for x square by x square plus 1, and please remember, you cannot just do the dx by x plus 2 was ln x by x plus 2. So this dx by x square plus 1 will not be directly ln modulus of x square plus 1. Alright, because we need to have a linear equation, and that also linear equation will be differentiated and the value will be divided. But here, this dx by x square plus 1, if you put x square plus 1, you will get something. But I have a better idea. Just let me do this first. You will see that we'll come to the same juncture. So where we are going to get x from here? We'll not get x. But after previous discussions of differentiation and integration, we already know that x square plus a square has a direct result. So integration of dx divided by x square plus a square, let me write it in a formal way. It will be equal to, if a equals to 1, it will be simply tan inverse x by a. So tan inverse x by a, x is what? It's x. A is what? 1. So it will be tan inverse x. So add a constant of integration if you want to all of this. This is 1 by 5 tan inverse x plus a constant of integration. So the formal result or the final result will be after cancellation of this 2 and 2 in the middle term. So let me write it formally. So this integration has come x square plus x plus 1 divided by x square plus 1 into x plus 2. This has become 3 divided by 5 log modulus of x plus 2. Now log base e it is. So you can always write ln in this case. So it will be 1 by 5 to the 2 got cancelled if you remember. Log modulus of x square plus 1 and then 1 by 5 tan inverse x. So this slight change here, it is x square plus 1. So this is how you can go about it. I explained you already. Now ax square plus bx plus c divided by x minus a into x minus b into x minus c. So this is a proper quadratic equation in the numerator, and x minus a, x minus b, x minus c in the denominator, and if you multiply them, the order will be 3. So the order of the denominator is higher than the order of the numerator. So we can have separate constant in here. That is, you can always write this as a divided by x minus a plus b divided by x minus b plus c divided by x minus c. Now we can take the LCM. So a will be, you just write the denominator, it will be easier for you. So when we write the denominator, it will be multiplication of x minus a and x minus b and x minus c. So this a will get multiplied, or a will have x minus b and x minus c plus b, x minus a and x minus c, and then c will have x minus a multiplied by x minus b. Now this is equivalent to the original one, which is ax square plus bx plus c divided by 3 factors, namely x minus a and x minus b and x minus 3 multiplied in the denominator. Now these 3 gets cancelled, so we can just regard this whatever is there in the numerator as equation number 1. Now we need to multiply these, or you can do one thing. If you put x equals to b, then the first term on the left hand side and the third term will vanish. Only the middle term will remain, and this b has to be on both the sides. You have to replace it on both the sides. So when we place x equals to b, the first and the third term I'm not writing because they will eventually be 0, and in middle one, x minus a is b minus a and x minus c is b minus c. This becomes equals to a into b square plus b into b plus c. So b became, from this equation, ab square plus b square plus c divided by 2 factors, which is b minus a into b minus c. So in the same way, we will find out the value of a and c also. When we place this x equals to a, what are we going to get? Now I'm writing x equals to a here. A into a minus b into a minus c will be equal to a into a square plus b into a plus c. Now this will give you what? A into a minus b, a minus c equals to a cube and ba plus c. So a has come like this: a cube plus ab plus c divided by a minus b into a minus c. Now let me just find out c also here, because it will be in the same frame then. X equals to c. Now when you put x equals to c, the first term and the second term will become 0, they will disappear. So c into c minus a into c minus b can be equated to ac square plus bc plus c. So c has become ac square plus bc plus c divided by c minus a into c minus b. So abc we have known now. Put it here, abc, and then just because these are constant, we can then just separate them out or keep it out of the integral sign, and we can just integrate 1 by x minus a, 1 by x minus b, 1 by x minus c in terms of dx. So if you assume that this constant is k, for example, so k will be taken outside, integration of dx by x minus b will only be done. So this integration will be like this. A was, if you remember, a cube plus ab plus c divided by a minus b into a minus c. What is being integrated? Whatever is inside, this will be dx divided by x minus a. Now coming to the other one, which is ab square plus b square plus c divided by b minus a into b minus c. And what is being integrated? Dx divided by x minus b. Similarly, the third one, which is x minus c, will be done in the same fashion after writing capital C, which we found out in earlier discussion. So ac square plus bc plus c divided by c minus a into c minus b, integration of dx divided by x minus c. Let me write the final answer now. So this will be ln modulus of x minus a, this will be ln modulus of x minus b, and the third one will be ln is basically log base c, so ln modulus of x minus c. So I am writing the final answer. There is nothing to take common because this is quite cumbersome, the different results. So we are not getting anything common. Even if you take a minus b or b minus a minus c and c minus b outside, there will be a lot of complication of negative sign, and then there will be certain things which we don't want, because this is already quite simple. So we have AQ plus AB plus C divided by A minus B into A minus C, ln modulus of X minus A, and then we have AB square plus B square plus C divided by B minus A into B minus C, and then we have ln modulus of X minus B, and the final time I am writing AC square plus BC plus C divided by C minus A into C minus B, and ln modulus of X minus C plus constant of integration. Now C is already there, so let's just change it. Let me write some K, or you can always write some P, which is a constant which always will come after indefinite integral. Now this will be the result, or this is the reference which you can follow. So only this is a standard result of the other question or the question which are going to be followed. This we will discuss in the later discussion. Till then, thank you so much and have a good one.